folks, so we're going to be starting on page 2 in the notes today. So yesterday we talked all about mad spam, and today we're going to be shifting gears a little bit to talk about polynomial operations. So I'm going to kind of separate this stuff. And the big thing with doing operations with polynomials is 1, recognizing what operation you have, and 2, combining your like terms. So looking at this first problem, I've got one polynomial, and I've got a second polynomial, and I want to subtract these two. What's your gut telling you that we should do with that minus sign? We did this a bit with complex numbers in Unit 4. In order for me to subtract this polynomial from this one, I am going to distribute that negative to both items in that parenthesis. That gives me negative 3x and positive 1. So 4x squared minus 5x plus 6. So I don't actually need those parentheses anymore. From here, we're just going to be combining like terms and putting our answer in standard form, which means highest power first. So we're going to put the 4x squared first. Then if we have negative 5x and negative 3x, we have negative 8x. And then a positive 6 and a positive 1, positive 7. We are not going to factor. All we are going to do is simplify as much as possible, get an expression in standard form, and throw a box around it. That's our final answer. So powers in descending order, combining like terms, and distributing that negative to both terms. Moving to our next one. What operation is going on between these two polynomials? Addition. So do I need those parentheses? Nope. We can remove them, and we can just go ahead and combine our like terms. Now you'll notice on this problem, I kind of boxed, circled, and underlined things to show that I was combining like terms. The reason I do this is I find it to be a helpful strategy to make sure that you haven't forgotten anything in your final answer. I will say, though, that I don't like it if students cross off their work so that I can't see how they got to their answer. So find a system that works for you and just make sure you have combined all of your like terms together. So I'm ready to combine my like terms since this is adding. So we've got 6x to the 4th. Does it have any buddies? Nope. So that's just going to be my first term. Then I'm going to look for my x cubed stuff. We've got negative 4x cubed. No buddies for that one. Any x squareds? Nope. Then we've got negative 7x and 9x, which gives us positive 2x. And then a positive 8. And the negative 5 gives us a positive 3. Final answer. That is how we add and subtract polynomials. So yeah, it's not so bad. Just with subtraction, make sure you distribute it into the second parenthesis. In addition, just go straight to combining your like terms. Now, moving on to our next problem. What operation is going on between those polynomials? That's multiplication. Now with multiplication, since there is a 2-term and a 3-term polynomial, we're not quite going to FOIL. We're going to do superfoiling or mass distribution. Call it whatever you like, but essentially we are going to be taking the first item and distributing it to everybody in the second parenthesis, and the second item, making sure we take the sign with it and distributing that to everybody in the second parenthesis. So I'm going to start by distributing the x, and the big thing on these problems, folks, just make sure you're taking your time. What's x times x squared, or x times x times x? X cubed. And then x times 4x. 4x squared, wonderful. And then x times 16 is 16x. So I have distributed that first x to everybody in the second parenthesis. Now for the negative 4. Negative 4 times x squared, negative 4x squared. Negative 4 times 4x, negative 16x. And negative 4 times 16 is negative 64. And we're done. Put a box around it, question mark. What should we do next? Combine our like terms. So after we carry out the multiplication, then we want to see if we have any buddies for these variables. So x cubed, any buddies? Nope. So x cubed stays x cubed. Then I've got 4x cubed and 4x squared and negative 4x squared. So what happens to those? Goodbye. And then I've got 16x and negative 16x. Goodbye. And then we've got negative 64. So, wow. All that work and all of those different multipliers we had, and we had a lot of cancellation, and we ended up getting just x cubed minus 64. Now, folks, Mr. Beal on Friday is going to teach you guys how to factor polynomials, which is essentially going backward and starting with this and turning it back into those factors. So I just want you to draw an arrow going back to that factored form, and I want you to call this difference of cubes. So for right now, we're working forward, turning factors into equations or distributing, and later we'll be going backwards. And if you're looking at that going, how am I going to turn that into those factors? It's a process. It's different than any of the other types of factoring that we've done before. It is going to take some getting used to, but it's very, very useful for factoring polynomials. Let's go ahead and move on down to our next one. What's different about this one? How many things am I multiplying? Ooh, there's 3 things. So we want to FOIL first. I'm just going to arbitrarily start with the first 2. So FOIL first. Another recommendation that will help you out with your like terms is to alphabetize the variables. So if I have 2 apple bananas plus 5 banana apples, are those like terms? Are these like terms?
Yes.
So remember yesterday when I said if stuff is all joined by multiplication, you can switch the order around? So 5BA is the same as 5AB. So these are definitely like terms, and I get 7 apple bananas or the ABs, whatever. So to make identifying the like terms a little bit easier, I do recommend that you alphabetize your variables, just because it does make it a little bit easier to see where those like terms are located. So let's go ahead and start by FOILing. So if I have 2a times 4a, 2 times 4 is 8, and a times a is a squared. Then 2a times b is 2ab. What about negative b times 4a? Careful. Excellent. Negative 4ab. Emphasis on the negative because sometimes students will miss the signs when they're focusing on the numbers and the variables. Then lastly, negative b times b, negative b squared. And then I had that 3b minus 5. Now, if I were you, before I go to distributing it again, I would simplify inside this parenthesis. If I have 2ab and negative 4ab, how many ab's do we have? Perfect, negative 2ab. So now it's distribution time, and I have 3 things I will need to distribute. I'm going to pass out the 8a squared to 3b and to negative 5. So 24a squared b. Then 8a squared times negative 5, negative 40a squared. Then I'm going to take the negative 2ab times 3b. So negative 6ab AB squared. And then negative 2AB times negative 5. So positive 10AB. See if you can do the last distribution on your own. So negative 3b cubed plus 5b squared. So, yuck. As I'm looking at that, I've got a squared b, a squared. Are these two like terms, a squared b and ab squared? No. To be like terms, it has to be the exact same variables raised to the same powers. This has a squared. This only has a. Folks, do I have any like terms?
No.
No. So what a bummer. This is our disgusting final answer. So sometimes when you multiply, you'll end up with very few terms. Sometimes when you multiply, you'll end up with a lot of terms. It's really easy to miss little details as far as the power number or missing a variable. So as I said yesterday, it's very important that you are checking your work carefully on the answer key. On your own, I want you to go ahead and try the next one. Multiplication, and this one is just straight up FOILing. Go for it. If it hurts your brain, x cubed times x cubed, we can actually write that out. What is x cubed times x cubed? Now this is more like what we were doing yesterday. We're multiplying the bases, so what will we do with the exponents? Add them, so x6, then x cubed times negative y cubed, y cubed. We got like terms that cancel. Final answer, x to the 6 minus y to the 6. And since we already kind of did a little preview with factoring on the above problem, I want you to write that this one is actually difference of squares. Now we've talked about difference of squares before, but only in the context of quadratics. Now we see that x to the 6 is a perfect square, because x cubed times x cubed is x to the 6. Y to the 6 is also a perfect square, y cubed and y cubed. One gets a plus, one gets a minus. And that's how we can factor that as difference of squares. Folks, does anybody have any questions so far? I also wanted to thank you guys. I had someone who was gone for an extended period of time who learned from watching the live lesson videos. They're like, that was great. Third block is awesome. So thank you guys for that. You guys are respectful. You guys volunteer answers here and there. So they were really, really appreciative of the live lesson. So thank you. Folks, let's go ahead and we'll pause. We'll stop the